During the early morning hours of a summer day in 1942, a Navy officer made his way across a California airfield toward an aircraft that represented one of the greatest intelligence victories of the Pacific War. The sleek fighter sitting on the tarmac bore fresh, American insignia, but beneath the new paint, traces of the rising sun emblem were still visible. This was a Japanese fighter, and what happened that day would fundamentally alter the course of aerial warfare for 8 months. This particular aircraft type had terrorized Allied forces throughout the Pacific. Pilots spoke of it with a mixture of fear and respect. Intelligence officers desperately sought information about its capabilities. Every encounter with this fighter seemed to confirm its superiority. American, British, and Dutch pilots were dying because they didn't understand how to fight it effectively. The concept of surrendering military equipment was completely foreign to Japanese military culture. Pilots were expected to die with their aircraft rather than allow capture. They would deliberately crash into the ocean or set fire to damaged planes before abandoning them. The secrecy surrounding Japanese aviation technology was nearly absolute. 4 months, Allied forces had collected fragments from crash sites and pieces of shot-down aircraft, but they had never possessed a complete, flyable example that could be thoroughly examined and tested against their own fighters. What intelligence reports revealed was sobering. This fighter could execute tighter turns than any Allied aircraft. Its climbing ability at lower and medium altitudes was exceptional. The range was remarkable, allowing escort missions that seemed impossible for a single-engine design. Japanese aviators exploited these advantages with devastating effectiveness, forcing close-range maneuvering combat where Allied pilots found themselves consistently outmatched. The statistics from early Pacific engagements painted a grim picture, with loss ratios heavily favoring the Japanese. Combat veterans described an aircraft that seemed to defy normal aerodynamic principles. They spoke of impossibly tight turning circles, of the fighter appearing to hang motionless in the air during maneuvers, while American fighters struggled to maintain control. Each mission, each loss, each encounter added to the growing legend of Japanese air superiority. What military planners desperately needed was concrete information about vulnerabilities. Every aircraft design involves trade-offs and compromises. The remarkable performance characteristics had to come at some cost. Without a complete aircraft to examine and test under controlled conditions, Allied forces were developing tactics based on incomplete information. Combat reports colored by the stress of battle, and educated speculation rather than engineering data. The aircraft sitting on that California airfield represented the end of uncertainty. It had crashed on a remote Alaskan island 5 weeks earlier during Japanese operations in the Aleutian Islands. The pilot, attempting an emergency landing due to engine problems or possibly combat damage, had chosen what appeared to be suitable terrain. The grass-covered field was actually waterlogged marsh. When the landing gear touched down, the wheels sank immediately into soft ground. The fighter pitched forward and inverted. The pilot, still strapped in his seat, suffered fatal injuries. He died instantly on that isolated island. The inverted aircraft remained hidden in tall grass for nearly a month before an American patrol discovered it during a systematic search of the area. Naval personnel immediately recognized its significance. A recovery operation was organized, equipment was gathered, and sailors used improvised lifting gear to right the aircraft and transport it first to Dutch Harbor, then to Seattle, and finally to San Diego for detailed evaluation to understand why this single aircraft mattered so profoundly. One must consider the broader strategic situation in mid-1942. The Pacific War was going catastrophically for Allied forces. Japan had achieved an unbroken string of victories. Hong Kong, Singapore, the Philippines, and the Dutch East Indies had all fallen. Burma was being overrun. Australia itself appeared threatened. At sea, Japanese naval forces had destroyed major British warships and devastated the American Pacific Fleet. Japanese submarines operated with near impunity across vast ocean areas. The strategic outlook was grim. The tactical situation in the air was even worse. Japanese pilots, operating from carriers and island bases, dominated wherever they appeared. Their primary fighter was the instrument of that dominance. The aircraft had been designed in the late 1930s by a brilliant engineering team tasked with meeting extraordinarily demanding specifications. The Imperial Japanese Navy wanted exceptional range for long over-water escort missions, superior maneuverability for air combat, excellent climb performance for intercepting bombers, and all of this in an aircraft light enough to operate from carriers with their inherent space and catapult limitations. Meeting these requirements demanded radical design decisions. The fighter carried no armor protection for the pilot. The fuel tanks lacked self-sealing capability that would prevent fires from bullet strikes. Heavy weapons were avoided to save weight. The airframe itself was built as light as possible using special alloys and construction techniques that eliminated every unnecessary ounce. The result was an aircraft weighing roughly half what comparable American fighters weighed. This minimal weight, combined with large wing area and a relatively powerful engine, produced performance that seemed impossible to Allied pilots encountering it. The turn radius was extraordinarily tight. The climb rate was exceptional. The range exceeded anything American fighters could achieve, allowing operations hundreds of miles from base dot in the hands of experienced aviators, men who had trained 4 years. The fighter was devastatingly effective. Japanese naval aviation training was among the most rigorous in the world. Candidates spent years in instruction before being considered combat-ready. They practiced constantly until complex maneuvers became instinctive. Physical conditioning was brutal. Discipline was absolute. By the time a pilot earned assignment to a combat unit, he was a highly skilled professional. These pilots had gained their initial combat experience over China starting in 1940. The Chinese Air Force, equipped with obsolete aircraft, stood no chance. Japanese pilots achieved extraordinary kill ratios, sometimes exceeding 20-1. They perfected their tactics against opponents who could barely fight back. They learned to trust their aircraft completely and to exploit every advantage ruthlessly. When war came to the Pacific in December 1941, Japanese fighters participated in the opening attacks. They provided air cover during the assault on Pearl Harbor, shooting down several American aircraft while suffering no losses to enemy fighters. The pattern continued as Japanese forces advanced, operating from carriers and newly captured airfields. They destroyed Allied aircraft on the ground and in the air with brutal efficiency. Over the Philippines, American fighters were outmatched. They were faster in diving flight and at high altitude, but in the low-altitude turning engagements that developed, the Japanese fighters dominated completely. Pilots who survived reported that attempting to match turn rates was suicidal. The Japanese fighters could reverse direction and position for follow-up attacks, while American pilots were still completing their turns over Java and Sumatra. British fighters faced identical problems. Aircraft that had performed adequately against German bombers could not compete with Japanese fighters in maneuverability. Dutch pilots flying obsolete designs were massacred. Allied losses mounted steadily throughout early 1942. Recovering the crashed fighter from the Alaskan island was not simple. The location was remote, accessible only by sea or seaplane. Weather in the Aleutians was notoriously unpredictable, with fog, wind, and rain creating hazardous conditions. The recovery team arriving in early July faced significant challenges. The aircraft was inverted and partially buried in soft ground. The propeller was destroyed. The landing gear had collapsed, but the airframe appeared intact, and critically, the engine seemed undamaged. An engineering officer supervised the operation. His team used hand tools and improvised equipment to excavate around the aircraft, creating space to attach lifting cables. They constructed a frame using wooden beams and metal brackets to support the weight without damaging the structure. After several days of careful work, they attempted the lift. Using block and tackle rigging, hand-operated winches, and physical effort, They slowly raised the fighter. As it came upright, they inspected the damage. The propeller needed replacement. The landing gear required repair. Some skin panels were damaged, but the overall structure was sound. When they opened engine inspection panels, there was no obvious internal damage. This was extraordinary fortune. Combat-damaged aircraft typically had catastrophic engine failures or structural damage rendering them unflyable. This fighter had simply flipped during an emergency landing. Everything else remained intact. They loaded the aircraft onto a barge and transported it to Dutch Harbor, where mechanics performed preliminary inspection. What they found excited the intelligence officers present. This was not merely an intact airframe. It was a complete weapons system. The machine guns were undamaged. The cannon were functional. The gun sight was intact. Even the pilot's manual and navigation charts remained in the cockpit. Readable after drying. The fighter was transported by ship to Seattle, then loaded onto a truck for the journey to San Diego. The trip took days. At each stop, armed guards watched the covered aircraft. Naval intelligence wanted no information about this capture to leak. If Japanese forces learned that an intact example was in American hands, they might modify tactics or redesign the aircraft to address vulnerabilities they knew existed, but assumed remained secret. At San Diego, the fighter was taken to a secure facility where engineers, mechanics, and test pilots gathered to examine it. They photographed every detail, measured dimensions and weights, and carefully disassembled components to understand their construction. The engine was removed and placed on a test stand where it could be run under controlled conditions while monitoring performance. What they discovered was both impressive and revealing. Construction quality was excellent, riveting was precise, welds were clean, components fit together with minimal tolerances. The manufacturing reflected high-level craftsmanship and attention to detail. But the design choices revealed the compromises Japanese engineers had made to achieve remarkable performance. The skin thickness was extraordinarily thin, averaging less than 1 millimeter in many areas. Engineers measured it at multiple points and were astonished. This thin skin saved weight, but provided almost no protection against battle damage. A single heavy machine gun round would tear through it easily. There was no armor plating anywhere except a minimal piece behind the pilot's head. The fuel tanks were simple aluminum containers without self-sealing capability. Self-sealing tanks, which American and British aircraft used by 1942, contained rubber layers that would swell and close bullet holes automatically, preventing leaks and reducing fire risk. This fighter's tanks had no such protection. A single incendiary round hitting a fuel tank would likely ignite it, and with tanks located close to the cockpit, pilot survival would be nearly impossible. The control surfaces revealed interesting design choices. The ailerons controlling roll were large and relatively heavy, actuated by cables running from the control stick through pulleys to the hinges. Engineers tested the control forces required to move these ailerons while stationary. They were light, requiring minimal effort. This would give excellent control authority at low speeds, contributing to legendary maneuverability. But engineers noted that control forces in flight would increase with airspeed due to aerodynamic pressure on the surfaces. The wing structure was a marvel of weight-saving design. The engineering team had used a minimum number of internal supports, relying on the skin to carry much of the structural load. This technique was not unique, but Japanese engineers had taken it further than most designers dared. The result was wings that were incredibly light, but also relatively flexible. Under high gravitational loads, these wings would flex noticeably. Under very high loads, they might fail entirely. Engine examination revealed a reliable, well-designed power plant producing substantial horsepower at takeoff and maintaining good power at altitude. It used a 2-speed supercharger to maintain performance as altitude increased. Fuel consumption was reasonable, contributing to exceptional range. The engine was air-cooled, eliminating the weight and complexity of liquid cooling systems, but making it more vulnerable to battle damage. After 3 weeks of examination and preparation, the fighter was ready for flight testing. Mechanics had replaced the damaged propeller with a spare, repaired the landing gear, filled the fuel tanks, and verified that all systems functioned properly. On that summer morning in 1942, everything was ready. The officer chosen as primary test pilot was an experienced naval aviator with over 1,500 hours of flight time in various aircraft types. He had flown fighters, bombers, and patrol aircraft. He understood aerodynamics and aircraft performance. Most importantly, he could evaluate objectively, noting both strengths and weaknesses without preconceptions. He walked around the fighter that morning, conducting the external inspection that every pilot performs before flight. He checked control surfaces for freedom of movement and proper adjustment. He examined the propeller blades for damage. He verified that the landing gear was secure. He looked for fuel leaks, oil leaks, or other obvious problems. Finding none, he climbed into the cockpit. The cockpit was cramped by American standards, but not unreasonably so. The seat was simple with minimal padding. The control stick was centrally mounted. The rudder pedals were adjustable. The instrument panel contained essential flight instruments. Everything was labeled in Japanese, but he had been briefed on the layout and function of each instrument. Naval intelligence had provided translated diagrams. He spent several minutes familiarizing himself with switch locations, control positions, and emergency procedures. The engine start procedure was straightforward, similar to other designs he had flown. The engine coughed, fired, and caught. Blue smoke puffed from the exhaust as the engine warmed. He monitored the gauges, watching pressures rise and temperatures climb into normal ranges. The engine ran smoothly, with the characteristic sound of a large radial. He tested the ignition systems, checking for proper response. Everything was normal. He tested the flight controls, moving stick and rudder pedals through their full range, while observers outside confirmed that surfaces responded correctly. Satisfied that the aircraft was airworthy, he taxied to the runway. The fighter handled normally during taxi, steering easily. Visibility over the nose was adequate, better than some other designs he had flown. At the runway threshold, he performed a final check of instruments and controls. The tower cleared him for takeoff. He advanced the throttle smoothly to full power. The fighter accelerated quickly. The tail rose almost immediately, improving forward visibility. At appropriate speed, he pulled back gently on the stick. The aircraft lifted smoothly, climbing at what felt like an impressive rate. He retracted the landing gear and reduced power to climb setting. The climb rate indicator showed over 3,000 feet per minute. This matched reported performance data. The fighter climbed like nothing he had flown before. At 5,000 feet, he leveled off and began basic handling checks. He flew straight and level, noting control forces and stability. The fighter was stable but responsive, requiring minimal input to maintain altitude and heading. He initiated a gentle turn, banking 15 degrees. The aircraft responded immediately, rolling smoothly. He reversed the turn. The response was immediate and predictable. He increased bank angle to 30 degrees, then 45. The fighter turned in remarkably tight circles. The turn radius was noticeably smaller than American fighters at the same speed and altitude. He could see why Japanese pilots favored turning engagements. In a sustained turn at moderate speeds, this fighter had a decisive advantage. Any American fighter trying to match this turn rate would either stall or lose altitude rapidly. But he had not been sent up just to confirm what everyone already knew. His mission was to find weaknesses, identify limitations that could be exploited tactically. He climbed to 10,000 feet and began testing at higher speeds. He accelerated to higher velocities, performing the same basic handling tests at each speed. Noting how the aircraft responded. At moderate speeds, the controls still felt light and responsive. At higher speeds, he noticed the controls becoming heavier, requiring more force to achieve the same deflection. This was normal aerodynamic behavior. What worked at low speeds required significantly more force at high speeds. At very high speeds, he attempted a roll. He pushed the stick firmly, applying the force he estimated would be needed based on experience with other aircraft at this speed. The fighter responded, but slowly, very slowly. The roll rate was perhaps 1/3 what he expected. He pushed harder on the stick, applying more force. The aircraft rolled, but the rate remained disappointingly slow. The ailerons felt mushy, not giving the crisp response they had shown at lower speeds. He rolled back to level, then attempted another roll. Same result. The aircraft would roll, but only reluctantly, requiring significant stick force and producing a sluggish roll rate. He repeated the test several times, varying technique and the amount of force applied. The result was consistent. Above certain speeds, the roll rate in one direction degraded significantly. He continued testing, pushing the speed higher. The problem became more pronounced. At even higher speeds, rolling in that direction was nearly impossible. The stick forces required were enormous, and the actual roll rate achieved was glacially slow. Rolling in the opposite direction remained acceptable, though also degraded from low-speed performance, but the asymmetry was striking and significant. After 40 minutes of flight testing, he landed and immediately requested a meeting with the engineering team and intelligence officers. What he had discovered was not just interesting, it was tactically exploitable. The fighter had a specific, repeatable weakness that could be used against it in combat. Above certain speeds, the aircraft could not effectively roll in one direction. Any American fighter that could maintain high speeds in combat would have an enormous advantage. The engineering team wanted to understand why this weakness existed. They returned to the captured fighter and examined the aileron system more carefully. What they found explained everything. The ailerons were cable actuated, with cables running from the control stick through guides and pulleys to the aileron hinges. These cables had a small amount of stretch under load, at low speeds with low aerodynamic forces on the ailerons. This stretch was negligible. The system worked perfectly, but at high speeds, the aerodynamic forces on the ailerons increased dramatically. The aileron that had to move upward to initiate a roll in one direction faced especially high forces because it was deflecting against the airflow. The cables stretched under this load. The pulleys flexed. The entire control system deformed elastically. The pilot would push the stick, applying force, but much of that force went into stretching cables and flexing components rather than actually deflecting the aileron. Additionally, the large aileron area that provided such excellent low-speed control became a liability at high speed. The aerodynamic forces trying to resist aileron deflection were proportional to the square of airspeed and the size of the control surface. The large ailerons combined with the flexible cable control system created a situation where control forces became excessive at high speeds. American fighters of the same era had different control systems and different design priorities. They used stiffer control systems with less flex under load. The ailerons themselves were smaller relative to wing area, trading some low-speed maneuverability for better high-speed control. Most importantly, American fighters were designed to fight at higher speeds where engine power and dive performance mattered more than low-speed turning ability. The tactical implications were immediately clear too. Intelligence officers analyzing the test report. American pilots should avoid slow-speed turning engagements where the Japanese fighter excelled. Instead, they should use hit-and-run tactics, diving from altitude, making a high-speed attack, and then using superior diving speed to escape. If the Japanese fighter attempted to follow, the American pilot should roll in the direction the enemy couldn't follow effectively while maintaining high speed. This would give the American pilot time to extend away, regain altitude, and set up another attack. This tactical approach was not entirely new. A fighter squadron commander had already developed a defensive tactic where two American fighters would fly as a pair, weaving back and forth. When a Japanese fighter attacked one aircraft, The other would turn toward the threat, forcing the attacker to break off or face a head-on engagement. The tactic worked by denying the sustained turning engagement the enemy needed to bring superior maneuverability to bear. But such tactics were defensive, designed to protect American fighters from being shot down rather than to shoot down enemy aircraft. The information from the captured fighter allowed development of offensive tactics. American fighters could now dictate the terms of engagement, using their strengths against Japanese weaknesses. The poor high-speed roll rate became an Achilles heel, a vulnerability that skilled American pilots could exploit ruthlessly. Naval intelligence compiled a test flight report along with engineering analysis and distributed it throughout the Pacific Fleet. The document was classified with distribution limited to fighter squadron commanders and their pilots. The report was detailed and specific, providing exact performance data at various speeds and altitudes. It described the strengths honestly, acknowledging superior low-speed maneuverability and climb rate. But it also detailed the weaknesses, particularly the high-speed aileron problems and lack of armor protection. Fighter squadrons received tactical bulletins based on this information. The guidance was clear and actionable. Never engage in slow-speed turning combat. Use altitude advantage to set up high-speed diving attacks. Attack from behind or from the side using brief firing passes. Do not attempt to follow in a sustained turn. If attacked, roll in the favorable direction at high speed to evade. The enemy cannot follow effectively. Use superior diving speed to extend away from the fight. Then regain altitude advantage for another attack. Marine fighter squadrons operating from forward bases received this information in late 1942. Marine pilots had been suffering heavy losses against Japanese fighters. The tactical bulletins changed everything. Pilots who had been fighting defensively, trying to survive against a superior opponent, now understood they had advantages they could exploit. Their fighters were slower in level flight and could not match enemy turn rate, but they could dive faster, had better high-speed handling, and were far more rugged with armor protection and self-sealing fuel tanks. Marine pilots adjusted tactics accordingly. They patrolled at altitude, watching for incoming formations. When enemy fighters appeared escorting bombers, the Marines dove from above, building speed, then made quick firing passes through the formation. If enemy fighters attempted to engage, the Marines rolled in the favorable direction and dove away, using the enemy's high-speed limitations against them. Kill ratios began to shift. By early 1943, Marine pilots were destroying enemy aircraft at rates that would have seemed impossible 6 months earlier. Navy fighter squadrons aboard carriers implemented similar tactics. A new fighter entering service in early 1943 was specifically designed to fight Japanese aircraft, using lessons learned from the captured example. This new fighter was fast, reaching high speeds at altitude. It could dive even faster, maintaining control at speeds where the enemy's ailerons became almost useless. It had excellent visibility from the cockpit, allowing pilots to spot threats and targets more easily. And it was tough, with armor plating, self-sealing fuel tanks, and structure that could absorb tremendous battle damage and still bring the pilot home. Pilots of this new fighter trained specifically in boom and zoom tactics. They practiced high-speed approaches, quick firing passes, and rapid disengagements. They learned to recognize when the enemy was trying to draw them into a turning fight and to resist that temptation. The results were dramatic. This fighter achieved extraordinary kill ratios against Japanese aircraft during the war. Much of this success came from superior pilot training, better tactics, and overwhelming numerical superiority. But the aircraft itself was designed around knowledge gained from testing the captured fighter. Japanese pilots, meanwhile, continued flying their fighters, largely unaware that Americans understood their aircraft's limitations in such detail. Japanese intelligence knew the crashed fighter had been captured. Reports reached Tokyo about an intact example found in Alaska, but the Japanese High Command did not know the aircraft had been restored to flying condition, extensively tested, and used to develop specific counter-tactics. Japanese pilots continued to employ the tactics that had worked so well in 1941 and early 1942, forcing turning engagements and relying on superior low-speed maneuverability. These tactics became progressively less effective as American pilots learned to refuse the turning fight. Japanese pilots reported with frustration that American fighters would no longer engage on Japanese terms. The Americans would dive, shoot, and run. They wouldn't stay and fight. From the Japanese perspective, this seemed cowardly. From the American perspective, it was simply intelligent use of their aircraft's strengths against the enemy's weaknesses. The mystique began to fade. What had seemed invincible in 1942 is increasingly vulnerable by 1943. The captured fighter itself continued to serve American interests throughout the war. After initial test flights, other pilots flew it, including comparison flights against various American fighter types. Engineers continued to study it, examining every aspect of its design and construction. The aircraft was eventually damaged beyond repair during a landing accident in early 1945. By then, it had served its purpose. The knowledge gained from testing it had been incorporated into American fighter tactics, training programs, and aircraft design. The Japanese fighter was no longer mysterious. It was understood. 4 Japanese pilots still flying these fighters in 1945. The situation was desperate. The aircraft they flew was essentially the same as the one that had dominated the skies in 1942. Some improvements had been made. Later variants had slightly more powerful engines, modified exhaust systems for additional thrust, and in some cases heavier armament. But the fundamental design remained unchanged. The fighter was still light, maneuverable, long-ranged, and fatally vulnerable to damage. American fighters, by contrast, had evolved significantly. New models were faster and more powerful. Multiple fighter types were dominating the skies over various Pacific battlefields. All of these aircraft could outrun the Japanese fighter. Most could outdive it. All had superior firepower, better protection, and more robust construction. Japanese pilots faced overwhelming material disadvantage. The contrast reflected broader industrial realities. American factories produced tens of thousands of fighter aircraft during the war. Japan produced far fewer, and many were obsolete designs retained in service because nothing better was available. American pilots received extensive training, often accumulating hundreds of hours before seeing combat. Japanese training programs, strained by fuel shortages and loss of experienced instructors, produced pilots with minimal preparation. By 1944, some Japanese pilots were being sent to combat units with less than 100 hours total flight time. The psychological impact on Japanese pilots was significant. Men who had trained 4 years and fought successfully in China and early Pacific campaigns understood they were flying obsolete aircraft against overwhelming odds. They knew American fighters were faster, tougher, and more heavily armed. They knew American pilots had better training, more experience, and unlimited ammunition and fuel. Some Japanese pilots, particularly experienced veterans who had survived years of combat, adapted their tactics as best they could. They avoided engaging superior American fighters when possible. They focused on attacking bombers where their weapons were effective. They used clouds, terrain, and surprise to offset their disadvantages. But for most Japanese pilots, especially the inexperienced replacements being rushed into combat in 1944 and 1945, survival was unlikely. The fighter that had once seemed invincible had become a death trap. Its lack of armor meant any hits were likely fatal. Its unprotected fuel tanks meant fire was almost inevitable when damaged. Its light structure meant it could not absorb battle damage the way American fighters could. Pilots died not because they lacked courage or skill, but because they were fighting in aircraft that were fundamentally inadequate for the war they faced. The story of the captured fighter is often told as a tale of intelligence, success, and tactical adaptation. It represents those things, but it is also a story about design philosophy and the consequences of specific engineering choices. Japanese designers created this fighter to meet specific requirements: long range, excellent maneuverability, and lightweight. They succeeded brilliantly at meeting those requirements. The fighter was exactly what it was designed to be, but the war it was designed for was not the war Japan actually fought. Against American industrial capacity, American pilot training systems, and American tactical adaptation, the fighter's advantages proved insufficient to offset its vulnerabilities. The aircraft that dominated Pacific skies in 1942 was obsolete by 1944, not because it had changed, but because everything around it had changed. American fighters became faster, tougher, and more powerful. American pilots learned to avoid the enemy's strengths and exploit its weaknesses. American tactics evolved from defensive survival to offensive dominance. The morning that test pilot climbed into that captured fighter and discovered it couldn't roll effectively in one direction above certain speeds, he found more than a technical limitation. He found the answer to a question that had haunted Allied pilots since the war began. The legendary Japanese fighter was not invincible. It wasn't even particularly good at high-speed combat. It was a specialized tool optimized for specific conditions, and those conditions were not the ones that characterized most Pacific air combat after 1942. The mystique was just that, mystique, not reality. Understanding the difference between reputation and actual capability changed the war in the air. It saved countless Allied lives. It helped turn the tide of the Pacific War. And it began with one crashed fighter on a remote Alaskan island, and one test pilot willing to push that captured aircraft to its limits to discover the truth.